This podcast is brought to you by VinZero. VinZero pioneers solutions and services to the AEC and manufacturing industries to support net zero targets. Visit vinzero.com to learn more about how organisations design, build and solve through digitalisation. From VinZero to you, welcome to our Think Future podcast series. Each week we'll share conversations with industry leaders from around the world to find out how they're thinking future. Subscribe to VinZero Think Future for access to more episodes, interviews and profiles. Markus Roselieb is founder of Chang Mai Life Architects and Chang Mai Life Construction and specialises in green and sustainable architecture, focusing on educational projects and high-end residential and commercial projects. His approach is based on modern, organic design using a combination of natural materials such as bamboo with 21st century engineering. Markus advocates architecture that is functional, sustainable and warms people's hearts and makes them smile. And he firmly believes, with the right knowledge, bamboo is a potent and versatile construction material that needs to be reconsidered for a better built environment. He joins us today to talk about why. Welcome to the program, Markus.
Thanks for having me, Anthea. It's great to be here.
Markus, you were formerly educated as a medical doctor and are now recognised as an expert in bamboo architecture. As the most awarded builder globally in this sector, what was it that inspired you to change your career?
Well, everything goes step by step in life usually. It wasn't such a sudden change in career as it seems. When I was young already, living on the Austrian countryside, we had to do a lot of things for ourselves. When I was young, there was no phone in the house and you couldn't just call somebody to fix things. So most of the time we just had to fix things ourselves, and I always enjoyed that. And then later on as a student, we were fixing up apartments. And then when I was a doctor, I started building house and designing, and it was always in my life from the very early age. And one of the fascinations I always had when I was young is going into empty buildings, big buildings, and try to feel the space, and had my hair stand up when it was a good building and nothing happened was a bad building. And so I was always intrigued by all these things. So architecture has been, part of my life all the time. I was lucky to grow up in Vienna, which has a lot of great architecture, and in Europe, and seeing things all the time. So looking at spaces and what they can do to people, if they're good and if they're not so good, is something that has followed me. And I've been observing this since I'm young. That's how it started, actually. Fixing things was, as I said before, was in my blood all the time. So when we had our beach house, I had to fix things, and it became frustrating because family was enjoying the weekend and every time there was something to fix. Because the salt air corrodes the steel, the concrete, everything. And so I was always wondering, isn't there anything better than those? Then I came across bamboo, and I realized that, bamboo doesn't rust, and at the same time it has a higher tensile strength than steel, and it's beautiful to look at, and it has a negative carbon footprint. And all that together, I started looking into the material, and I was looking into earth and architecture. I always liked the adobe houses in Mexico or Africa, also the round houses in China. And, they're hundreds and thousands of years old and they still look cool. So I realized that there are materials out there that can do the job that I was looking for, but nobody was using them. And so I was looking, why is nobody using them? And then I realized the only reason, or two reasons actually why. One reason is that there's just not enough knowledge out there and skill set. And the other reason is, human beings are like a herd of sheep. This guy is doing it, and if he does it, it's better I do it too. Why should I jump out and do something new? So if everybody's doing it, there must be the right thing. And if it's the right thing, I'll do just that. So very difficult to change a trend, or look into things when everybody thinks we already got the best thing.
Of course. And you're certainly starting to make some impact now. So it's great to have you here today to talk about and educate the audience on the use of bamboo. I have to ask rather cheekily, coming from a medical background, is there any similarities between, say, the stability of the structure of bone versus bamboo?
This is one of the things that are a little bit difficult to answer, in the sense that when you start something, it doesn't matter which profession it is, there's always an area in that profession that comes easier and an area that is more difficult. And for me, the structural part, the anatomic part, the surgical part was always the easier part. I always understood how forces have effects on our body. And the bone is a fascinating structure because it has the microstructure of the bone adjusts to the efforts that we do, to the movements that we do, to the activities that we do, and compensates for them. Your bone structure will change whether you do a lot of bicycling or only sitting, or whether you will do running. The microstructure I'm talking, you won't see it on the surface, but the inside, how to absorb the impact of the forces. And I always understood that part very easily. So structural implications is something I always understood. And then there came bamboo. And suddenly there is a material that is has two different forms. Naturally, one is a tube and one is a rod. And the difference between a tube and a rod is that a tube is very difficult to bend. It's a very strong structural component. That's why they're using steel tubes everywhere, right? And the rod also is strong in terms of taking loads, and it is more bendable. So there's different implications on how you use things. But having had this understanding because the microstructure of the bone are little trabeculars and forms that, like in a church, that come together on the top and therefore distribute forces. And so when I was looking at working with bamboo, it very quickly became clear to me how to use the material and see the advantages of a natural tube that actually has even reinforcement by the little sections that it has. So it's a very strongly built material that is at the same time lightweight, much lighter than steel, but even has a higher tensile strength. So I was fascinated by that.
Certainly explains why you see a lot of bamboo, tubular bamboo for scaffolding used in Asian countries.
Yes, absolutely. I mean, the fascinating things about the scaffolding is also, not only it goes up 50, 60, 100 meters, but when they did this, nobody calculated the total weight of this scaffolding on the lower part, right? They just put up the scaffold and it's all the same. And that's the thing with bamboo. It has such a high compression and tensile strength that nobody even had to calculate and think, okay, if I go up 60 meter, the top one doesn't have much load to carry, but the bottom ones have a lot to carry. But did they really compensate for it? Yeah, maybe a little bit, but not a lot, because they didn't have to. The bamboo is lightweight and at the same time incredibly strong.
So when it comes to using bamboo in architecture, what are the design principles that are used?
So there we have to come back to the kind of bamboo we use. The renaissance of bamboo actually took place in South America, in Colombia. That's where they first started to, in modern ways to use bamboo. There were several famous architects, Simon Velez, Oscar Hidalgo, and then there was a German professor who came to play, Professor Liese, who's the first one who really looked into the microstructure of bamboo. And that kind of started the whole business, where they finally started to understand that bamboo is a strong material if you know how to use it, how to harvest it, and how to design for it. So when they used bamboo in the early days in South America, they have mainly one kind of bamboo that they use. It's called guadua. It's a very big bamboo. So it's a big tube, heavy and big. And at that time, so they basically designed like they would design a steel building and then just exchange the bamboo for the steel for bamboo. And that had several complications with it, because steel you can weld together, but bamboo you can't. So the connections become the important part. And if you understand leverage, if you have a 9-meter long pole and you pull on one end, the force on the other hand is tenfold. And the connection actually is only a connection between the thin walls of the bamboo, whatever you put in between. So there were kind of limitations by the kind of bamboo they used and the way they used it. And when we started, we had to start from zero. I didn't know anything about architecture, about bamboo in that sense. So we copied what they did and we looked at what worked and what didn't work. And I quickly realized that limitation, because where the connections are, the bamboo would crack very easily, and then the whole structure would become unstable. So I looked at different ways of doing it and realized we have so many different kinds of bamboo around the world and also here in Thailand. And I found a smaller kind of bamboo that is full of fibers that almost has no hole in the middle. It's like a steel cable. And if you bundle several of these together, it's really like a steel cable. You have several fibers that each of them has fibers inside, and together they make a bundle. It becomes incredibly strong. At the same time, when we do that, we eliminate the problem with the connections because a bundle can be endless. And once we understood that, we also realized, okay, now we can go beyond the box, beyond the rectangle and beyond the triangle, because these forms are actually not the forms that bamboo is good at. And since then, we've been building a lot of, natural curves or irregular curves and all kinds of structures that are intuitive and not really designed with geometry on the computer, but this, intuitive design. And we find that in the end, this is much stronger.
So let's just talk about one of those designs at the moment, which was the Panyaden School project. What did you find most challenging about that project, and how did you overcome the challenges that you came across?
It was incredibly difficult in the beginning because we didn't know anything, right? So we just started building and got some crews who had a little bit of knowledge, and then got some people from other parts of the world to give us advice. And people were not always saying the same things too. So we just started doing things. And from the earthen walls, different kind of earthen walls, rammed earth or adobe bricks or wattle and daub, to the bamboo structures, at that time, still a lot of the triangular stuff.
My understanding is it has over 51 and 2-story buildings and a sports hall and a library. Quite a big project for your first project. How did you procure so much bamboo?
Well, we have to be clear that Panyaden School was built over 10 years. I mean, we would never had enough people or material to do it in one. Also, we didn't really understand that much about the school business in the beginning. So, we started with the kindergarten and the first years of primary school. And then every year we added another year of school and other buildings, other year of school. And the longer we're in the business, we understood better what kind of buildings we need. And I understood better how to design and build them. So there is this total involvement in both sides, in the software and hardware of running a school and also in running architecture and construction business.
And one of your passions is combining the art of the old, for example, the use of bamboo, with the latest technologies, isn't it?
Exactly. I mean, it was the biggest obstacle that we faced for the school as well as for my bamboo architecture is the image that bamboo has in the minds of people, especially in the tropics, because they live with bamboo and for them it is poor people's timber, they call it, right? And they have the feeling that bamboo is not strong, it doesn't last, it's cheap, it's just, the last thing you want to use. And the reason for this is that there is so little knowledge in the area that bamboo has many phases in its growth. In the first year, bamboo is food. It's full of starch. It's like a young asparagus. It's really yummy. But the older the asparagus gets, the more fiber it gets, the less yummy it is. The same with the bamboo. They wonder, why do all animals come and eat it? Because the panda bear, the elephant, insects all love the starch and eat it, right? And there we had to fight the image that bamboo is not good, is weak, is cheap and all this. My idea always was to bring these materials into the 21st century. The school, as well as my architecture, was never done to serve fringe groups of the society. I never went with bamboo as the most sustainable construction material as my front play, because then I will only attract a certain group who are already convinced. Nothing changes if I build something for them, zero. But if I can build something where people come in that first say, oh, this is actually pretty cool. And then they come and say, actually, I should build my house like this. Then I have achieved change. Then we can talk about, reducing carbon footprint on a bigger scale and also just making people happier. Because I think what we can see is with the round shapes, with the soft materials, and so we can touch people's hearts and actually improve their quality of life. And because we can do that, things can change.
So what are some of the technologies that you're combining when you're making these award-winning structures?
We try to find things that are functional but also are things that, for example, teenagers of the 21st century are familiar with, or are part of their daily life, or is something they think is cool. For example, people usually, when they live in earthen or bamboo houses, they want only natural ventilation and daylight. But life is not like this. In Chiang Mai, we have 5 degrees in winter, 45 in summer. It's a huge span. Open buildings don't work. It just doesn't work. It's too cold or too hot. 13, 14 years ago, when we started, the climate was different. We could get by with natural ventilation to a certain extent. We only had 4 days of 40 degrees in summer. Now we have a whole month of 45. Different. So what we then did is we started, looking at how can we use this material to advantage in the current system of society, the current ecosystem. So we found a company that has the latest technology in air conditioning that doesn't just blow cold air in your neck, but that has little things on the top that just let cold air sicker down. And because our walls insulate very well, and because that system is very special, we use very little energy to cool the rooms compared to the systems that are in place in most other big buildings. Also because the air in Chiang Mai sometimes is very bad because people burn the woods, the fields and everything. We put into system, we were the first school that put into place a clean air system where we have machines that purify the air from the outside, that go through several filters and blow it inside. And the advantage of this is not only that the air inside is clean, when outside it's almost not breathable, it's also oxygen comes into the room on a regular basis, because closed rooms with lots of kids, oxygen levels drop, everybody gets tired. But with this system, we have cool, clean and oxygenated air. So it's an optimal learning environment. But also our chemistry lab is one of the best, or is the best equipped chemistry lab in the country in a high school. We have virtually everything that you can have like a university in there. So when the kids come in, they expect, sit on the flower and plant green and all this, but no, it's a complete lab. But it's in a building that's built from earth and bamboo. And then they see technology and these materials actually go together. Or when they come into school, we have an AI that scans their faces and checks with their temperature, they're sick, who is it. So only people who are in the database can come in, and we know who is at school and who isn't and when they leave. And so all these things show the kids that these are things that are compatible with their understanding of how the world runs today. And thus, they're much more open, and then they see the advantage of the rooms, and they love the kind of forms that we do. And that opens it up for them to have a positive attitude towards natural materials, much different than their parents, who grew up in little concrete boxes and are very skeptical about it. So they will be, when they leave, they'll be ambassadors for natural materials because they've lived in it. They've seen the fun and function of it.
Absolutely. And education starting early is a very big part of the change that we need to make when it comes to building for a more sustainable future. So you talked before about the changing climate just in Chiang Mai. What is the ideal climate for using bamboo? And where have you seen bamboo used successfully outside of Thailand, for instance?
I mean, that's a good question. Of course, the climate where bamboo can use easily is where it grows. I mean, that's an obvious thing. And how to extend it into other climates? You see, we have to see that when the human race first came into contact with iron, I don't know what, 2,500, 3,000 years ago. I'm not that good in history, but it was quite a while ago. And then started to, improve that material. So it became steel and then stainless steel and then blah, blah, blah. So I think we have a 2,000-year, 3,000-year history with iron. And then of course, the last century with all the industrialization, all the money that went into the research and developing this material to all the things we have. This is why we have building with steel and concrete these days. The bamboo revolution is now maybe 30 years old, and how much research has gone into bamboo in those 30 years? I don't know, $100,000 is compared to $1 trillion into steel. So what I want to say is, these are the first baby steps we're taking by using bamboo in architecture, the way I see it. And even I can improve what I'm doing by just using my eyes and my experience in my team every day. But if we have a global effort where, researchers from all kinds of viewpoints and from all kinds of places come together, I think there's no end to where bamboo can go and how it can be used. I'm pretty positive that we can build skyscrapers with this material. Why? Because it's just a better material. We just don't know enough, that's all.
Are you looking for a digitalisation and net zero partner to help you achieve your goals? Join the thousands of AEC and manufacturing customers globally who have turned to VinZero to start their journey toward a net zero future. With 32 offices around the world, VinZero can connect you to the right technologies and workflow processes so you can maintain your competitive position and increase profitability. VinZero has an industry expert to help you navigate the best pathway forward, wherever you are on your digitalisation and net zero journey. Visit vinzero.com to find out more. So what sort of standards do you use for bamboo over other timber products, for example? And does building with bamboo affect things like the build time?
Luckily there is a lot of research out now on bamboo, a lot from German universities, but from all over the world, and now even in Thailand. Interestingly, of course, a tropical country were the last ones to jump on this bandwagon, because for them bamboo was, that the image was too strong, it was too negative. For countries who didn't have this negative image, much easier to jump on. So in the moderate climates where there's less bamboo, there's a lot more research. We understood much earlier what kind of great fiber that is. So when we build the bigger buildings, I'm using engineers to calculate how to build trusses. So these are actually, calculated like any steel truss. Our bamboo trusses are calculated just like that, with computer models about wind, about earthquake, about loads, about shear force, and how many bamboo columns I need on the lower part and the higher part of the truss, how to connect them. So this is all actual science by now. I mean, you cannot compare bamboo and timber, because timber is just what it is, a plank, or it is not a tensile element like bamboo that is flexible and can be incorporated into a truss. It has to be engineered into a truss if you want to use timber. You have to make the beams to glue lamb or whatever in order to get to that. And even bamboo is now used glue lamb-like in beams, and it's lighter, it has a higher tensile strength and so on. So I think in many ways it will replace even timber in these areas.
Are you experiencing any regulatory or policy type of constraints when you're building or proposing to build with bamboo?
Yeah, of course. I mean, I'm glad I'm in Thailand, and Thailand is known for always finding a solution out of every corner that there is, and most of things are clearly defined in a gray zone, because there's no black and white in life. So I'm very comfortable with that way of looking at the world. But bamboo is classified as temporary construction material in the building code, and that would prevent us from doing a lot of things. But in the actual construction code, the way how to allow the construction is also clearly defined in a little bit different ways that not directly contradict that, but open opportunities to build things like an open space under 150 square meter with an extraction time of people under 10 or 20 seconds doesn't need a building code, doesn't need a building permit. Or if it's over 300, then the building code has to be done in this and this way. So we can conform with a lot of the codes. And because we also give and take, for example, if we build a building like a classroom, I know that the local engineers who authorized the construction couldn't live without some concrete and steel in there. So our foundations are reinforced concrete anyway, but then we put some columns into the walls that take the load of the roof that are reinforced concrete. We then put it into the earth so you won't see it. He gets his columns, we get our earth, he gives us our approval for construction, we are all happy. So as you have to find a way to make everyone happy, and then things can go. But if I wouldn't be in Thailand, I wouldn't be where I was. If I would be in Europe, forget about it. Nothing would have moved.
So how do we drive the change that's needed in order for other regions to open up the opportunity to build with products like bamboo?
But you see, this is the interesting thing. So me building here in Thailand like this has inspired many all over the world. So I won the awards in Europe, I won them in America, I won them in all those countries that wouldn't have allowed me to build like this, you know? That's the funny thing about this. So they all come later and say, that's cool, that's great, now we want this too.
You mentioned earlier on when you first started building with bamboo that there was issues with the longevity of how long it would last for. So now that you've discovered the secret formula and the right type of bamboo to use, how long do you expect these structures to last? And is there an opportunity for circularity in any format?
I mean, the way we use bamboo, there's a lot of circularity to start with because all the cut-offs from the big trunks are then made by my guys into bamboo nails, because all our structures is not done with steel nails or screws. Everything is connected with bamboo nails. And whatever other cut-off is there is burned in a little oven that's called a wood vinegar oven, and that extracts a fluid through the burning process, and that wood vinegar is then used against termites. So the whole bamboo is a total circularity thing. At the same time, the bamboo structures itself, they will last as long as any other wood structure or so. If you're not exposed to sun and rain, it doesn't go anywhere. The bamboo is preserved, is well chosen. The insects don't go in. There's no visual or other degradation that's happening. So, all the buildings I've done definitely will outlast me and probably my children. The only thing that has to be looked at is everything that's exposed to rain and sunshine, of course. Like with wood, everything gets lighter, gets grayish in color. As long as it's just a color change, that's fine. And, the small parts on the roof, they will degrade and have to be replaced after some time. We just replaced some of our first roofs that are over 10 years old. At that time, we didn't have very good material. We didn't have a lot of knowledge. So our later generations of roofs probably will last longer, 15 to 20 years. And the more we know, the longer they will last.
Do you treat the bamboo with anything to prevent colour loss or to provide extra strength?
We treat bamboo with a boric acid solution, mainly to prevent insect infestation. Also, the borax is a preservative. It just preserves things. It's used in food in Thailand, in the meatballs still. And it's also a fire retardant. So it helps to prolong the time until the bamboo catches fire, which is from the beginning already has a much higher fire point than many wood. So in the end, if you look at flaming codes, a lot of the wood that is allowed for example, in Thailand's construction code will burn much earlier than the bamboo.
Is there anything else you're passionate about sharing when it comes to bamboo?
I'm passionate about architecture that impacts lives, that changes life on the smaller and bigger scale. And I find with bamboo having so many advantages in the structural part, and also that it is, carbon negative. It absorbs carbon during its production, unlike steel that releases a lot of carbon. It is good for the planet. But I also find that the buildings that we do talk to people's hearts because of the design, but also because it's a natural material. I mean, nature has this ability to touch our hearts, right? If we think of a great holiday, we'll probably think of a beach, a mountain, something close to nature, right? Walking along a stream. Why? Because when we're with nature, we get peaceful, we get calmer, we get happier, right? So nature has this ability, and we try to use this to build houses that people really can connect to, that they can be touched by, and therefore just have a better life. And because people are touched by the buildings they live in, they take better care of it. Thus, they're more sustainable. They become more functional. So all of these things go hand in hand once you can deliver this warm quality, and the bamboo and the earth help a lot with that.
So, Markus, I have to ask you as we come to the end of our conversation today, when you think future about the opportunities for the built environment and materials such as bamboo, what is it that excites you the most?
What excites me where we are now and where we are going is that we are on the forefront. So there is nothing really that stops us. Everything we do is new. Everything we do is something people want to see, want to hear, want to publish, and that pushes us also to come up with new things as much as we can. I really don't like repeating what I've done before. Sometimes the clients ask me I want this, And even then I try to give it a little twist, to find a new step, give it something a bit different to what was there before. And I think this, looking at every project that comes in as something, understanding the project and saying, what else can we do that we haven't done yet? Where else can this material and our design take us next? And, in the big vision, seeing something that really, that in the end, the bigger and the more unexpected, the better. That if the environment is different, the thing that captured most people was our sports hall, because it has huge trusses, and these trusses looked like steel trusses, which was unexpected, plus it was big. So I know these are the things that really change people's attitudes and minds. And I think we need to do things that enhance this change of thinking, that we do not need to ravage the earth for more steel and for more concrete all the time, because these materials are already there and they can do most of the job. And we are the ones who have to prove that. So, I like to be in the position that we are now, that we have responsibility, we have opportunity, and we have to be as creative as possible.
Well, it's certainly great to have an organisation like Chang Mai Architecture as a leading change maker for the built environment, and great to hear about your vision for the functionality of bamboo. So thank you very much for sharing the insights today, and we look forward to hearing about more of your award-winning projects in the future.
Thank you so much. Thank you so much. I'm really very proud that you chose to have me on your program, and I wish you a lot of success with it as well.
This podcast was brought to you by VinZero. VinZero help the AEC and manufacturing industries keep pace with digital change and achieve their technological and sustainability leadership goals. VinZero is a company that cares about creating and building a better world. Together, we are working with industry and environmental experts, providing forums and platforms through our VinZero Think community to create conversations that matter to our future generations. We invite you to join in the conversation and participate in our Think community. Like and subscribe to Think Future to stay up to date with the latest innovations and conversations as we take AEC and manufacturing around the world closer to zero. You can download our podcasts at vinzero.com or from your favourite podcast platform. From VinZero Think Future, thanks for listening.